For those who see the world not as it is, but as it can be, who seek to make their vision of the future become reality, their mission is our mission. At Lockheed Martin, we never forget who we're working for.
So my name is Emily Lakdawalla. I'm the senior editor and Planetary Evangelist for the Planetary Society. The Planetary Society is the world's largest space interest organization with members all over the world. We advocate, we educate, and we innovate about space research and exploration. My title is Senior Editor and Planetary Evangelist. I write about space research and exploration for the blog at planetary.org/blog. My background is in planetary science. I started out as a geologist, and then it occurred to me to ask the question, can you do geology on other planets? And it turns out that you can. And I went back to school to do just that, and now I'm a planetary scientist. But I'm here to tell you that all of you in this audience today are very likely also planetary scientists, because it takes one big qualification to be a scientist, and that's curiosity. Okay, curiosity. It's asking questions about the universe and seeking answers to those questions. So I thought that I would take us on a little bit of a tour. One of the big reasons that I like space science is because the questions that scientists ask and that we're trying to answer about our solar system are very easy to understand. And a lot of the questions that the real-life scientists doing research right now for work are the same questions you guys very likely have about what's going on in the solar system. So I'm going to take us to 3 different places. I'm going to take us to one place that we've studied a lot, one place that we've only recently seen for the first time, and one place that we've never been before, and explore that for the first time. So the first place I'm going to go is Venus. Venus we've explored a lot. We've explored it ever since the 1960s with the very first interplanetary spacecraft named Mariner 2. This is a photo of Mariner 2 under construction. Now, Mariner 2 taught us a lot of the basic facts about Venus that you will learn if you pick up any solar system textbook. Mariner 2 taught us, for instance, that Venus rotates very slowly. It taught us the fact that Venus has an atmosphere that's made of carbon dioxide that is so thick, it is 90 times denser than the atmosphere on Earth. It would crush you instantly. Okay? It told us that Venus's surface is so hot that it would melt lead if the metal lead were exposed on the surface. It's a nasty, nasty place. And it also taught us that these clouds that you can see in this artist concept are actually floating 60 kilometers above the surface, about 40 miles above the surface. So that's a bunch of facts about Venus. That's what you might learn if you open up a textbook. But we still have a lot of questions about Venus. So let's all go to Venus. This is what you would see if you were in a spaceship flying past Venus. This picture was taken by Messenger in 2006 when it flew past Venus on the way to Mercury. This is a true color picture of Venus. This is what you would see with your eyes. It looks really, really boring. It is white. It's a cue ball. It's absolutely featureless. It's really hard to see. But if you came prepared and you had some ultraviolet glasses that you could put on in front of your eyes, you would get to see this. And this is what Venus looks like in the ultraviolet. Now, a lot of you may be asking the question, what is this dark stuff that's tracing out shapes in Venus clouds? It turns out the answer to that question is we don't know. Okay, we've been studying Venus for 50 years with the Venus Express spacecraft, with numerous American spacecraft. Venus Express is European, and with Russian spacecraft. That dark stuff in Venus's clouds is really, really convenient because it traces out the shapes of the clouds. You can actually watch the clouds move across Venus's sky with an orbiting spacecraft like Venus Express. With the help of this dark stuff in the clouds. We've been studying it for 50 years, and we still don't know what it is. I love the sequence. Venus Express takes these images all the time, continuously, as it's orbiting Venus. So that's one question that scientists are asking that you're asking too. Now, one thing that we do know about Venus's atmosphere is that it's made of carbon dioxide. And this is a little bit strange. It's strange that Venus's atmosphere is so thick and made of carbon dioxide, because if you look at all the other terrestrial planets, we have here Mercury, Venus, Earth, the Moon, and Mars, you would expect Venus and Earth to be very similar. Okay, we look at the two of them. They're very similar in size. They're in a very similar position in the solar system. Venus is a little closer to the sun, but not by a whole lot. But they're actually quite different places. Now, one of the things that makes the atmosphere so different is the behavior of the element carbon. Both planets started out with the same amount of carbon. They started out with the same number of carbon atoms. But the carbon atoms are behaving very differently on Venus than they are on Earth. On Venus, all those carbon atoms are floating high up in the sky in the form of a gas called carbon dioxide. So Venus has blown its entire carbon budget on atmosphere. All of its carbon is up there in the sky. On Earth, all of our carbon is locked up into rocks. Pretty much all of it is. I've got here a picture of the mineral called calcite, calcium carbonate. It's the main mineral that makes up limestone and marble. Most of our carbon is in that, either that or things like coal and stuff. A little bit of it is in this gooky skin of stuff called life on the surface of the Earth. But very little of it is in the air. Why is all of Venus's carbon in its sky? You guys know what the answer to that question is? We don't know. Again, we've been studying Venus for a long time. We don't know the answer to this question. It's one of the things that motivates Venus research. Now, it could be that the answer to this question about why Venus and Earth have different skies could be on the surface, but Venus's surface is very hard to see thanks to that thick cover of clouds. Well, engineers love a challenge. So in the 70s and 80s, the Soviet Union designed a series of spacecraft called Venera to penetrate beneath those clouds and actually take photos of the surface. Here's a couple of pictures of one of the Venera landers under construction. The guy over here is working next to the camera. The camera is behind that red cover. It's a thing that swept back and forth and was looking down at the ground very close to the lander, and then it could sweep up and go up and see the horizon. And so that's what you'll see in the pictures that I'm going to show you here. These are the first pictures taken of the surface of Venus by the Venera 9 spacecraft in 1975. That is Venus. There's broken up chunks of rock covering the surface. They actually successfully landed on Venus several times. They took pictures 4 times. The last 2 times they had color cameras with them, which were really cool. And the most exciting photo, I think, is the one on the bottom that was taken by Venera 14 in 1982. Look at those rocks. They look kind of like somebody poured syrup on the ground and it spread out, right? They're very goopy looking. Those are lava rocks, just like the lava rocks in Hawaii, you know, that black basalt that flows out in sort of a goopy way on the surface. Those look like very fresh lava rocks. And this and various other characteristics of Venus tell us that there was volcanism on Venus very recently. Maybe it's possible there could be volcanoes on Venus erupting today. We want to know the answer to that question. We don't know the answer to this question. We've been studying Venus for 50 years and we still don't know the answer to that question. A lot of our questions about Venus can be boiled down to one big overarching question, which is why are Venus and Earth so incredibly different from each other? Again, we don't know the answer to this question, but this is a very important question for us to try to figure out the answer to. Because remember all that stuff that I said about carbon? We are currently taking carbon from Earth's rocks, and we are putting carbon from Earth's rocks up into the atmosphere. We are making Earth more like Venus every day. And I love Venus. I love all the planets. I love their diversity and their difference from Earth. But I like Earth a lot more. I think it's a much nicer place to live than Venus. And I would like to know if we are going to turn Earth into Venus because of what we're doing with the carbon. So that's one very important thing for us to study, a very important question for us to answer. Okay, so let's go to a different place in the solar system. Let's try out, I thought we could go to Mercury or maybe the moon or Mars, but I thought I'd try to bring you to a place that we haven't explored very much before. I'm not sure if many of you have even heard of it. Here's a photo of that location. It's not very easy to see. Let's try to blow it up. It's still pretty fuzzy, okay? This is a picture taken by the Hubble Space Telescope. Prior to 2010, this is the best photo that we had of a place called Vesta. Vesta is the 3rd largest asteroid in the asteroid belt. It's an asteroid with an interesting and varied surface. We could tell that from Hubble. We know that Hubble told us that the asteroid was very, very lumpy, which is kind of strange because it's a very big world. It's awfully big to be so lumpy. We didn't know the answer to this question. We wanted to find out why. We weren't just interested in Vesta because we were interested in Vesta for its own sake. We were interested in Vesta because it's part of something called the asteroid belt that orbits there between Mars and Jupiter. Vesta likely represents the kind of thing that built our planets to begin with. There used to be all these little rocks and bigger rocks came together, and eventually we formed the terrestrial planets. The asteroids are a place in the solar system where that formation process couldn't finish because Jupiter's gravity disturbed them too much. And so Vesta is possible. It could tell us a little bit about where we came from in the first place. It would be great to learn more about Vesta so we can try to understand Earth. Again, these are the basic questions that are driving active space exploration right now. Finally, what I would like to know about Vesta is what does it look like up close? Because it looks so lumpy and interesting in the Hubble photos. I would be awfully curious to find out what it looks like up close. We can find out what it looks like very close because we think we have meteorites that came to us from Vesta. This is a photo of a meteorite that landed on Earth, and there are certain characteristics about it that tell scientists that it very likely came from Vesta. We have hand samples of this asteroid. It's one of the few places in the solar system where that's true. So if we could kind of bring that together, go see it in space, look at our hand samples on Earth, we might be able to find out more about how the solar system formed in the first place. So in 2007, we launched a spacecraft called Dawn to go and find out what Vesta looked like up close. Dawn had to travel for 4 years in order to get to Vesta. And this was our first photo that Dawn got of Vesta. It's also not very impressive, okay? But Dawn at least was a spacecraft, and we could get closer and closer. Here are some of the first photos that actually showed features on the surface of Vesta. But it was still really hard to understand what was going on. I see a lot of faces in this. It's kind of funny. If you don't know what's going on the surface of another world, you see faces all over the place. It's hard to blame Richard Hoagland. But we were able to get closer with the spacecraft, and Vesta started coming into focus, and we started seeing it as a new world that nobody had ever explored before. Just think about that, guys. This happened in your lifetimes. We saw a whole brand new world that no human had ever seen before. We saw some things that were very familiar. You can see bowl-shaped impact craters on the surface, and we saw things that looked very unusual, like the strange nose that Vesta seems to have on its southern hemisphere, and these kind of weird, groovy, wavy features that are crossing its surface. So now we've answered one of our questions. Yay! Okay, once in a while you do get to answer a question. We know what Vesta looks like. We also know why it's so lumpy, because it has a gigantic impact basin at its southern hemisphere. But when we started looking at these impact basins more closely, we came across another mystery. That impact basin at the southern pole of Vesta that gave it its funny shape is not the only one at the southern pole of Vesta. There are 2 impact basins right at the same size, in the same place on the southern hemisphere of a tiny little world out in the middle of nowhere. How could Vesta have been hit in the same place twice? We don't know the answer to this question. It's still a mystery that we're trying to solve. We got even closer to Vesta. We got some beautiful photos showing these amazing groovy features. And once we started looking at the craters more closely, we found some very bizarre features of those craters. For instance, there was this cluster of craters. What do you think the scientists and engineers on the mission called this cluster of craters? Ed, shout it out. It's a snowman, okay? These are the snowman craters on the surface of Vesta. And how do we get so many impactors hitting in the same place at the same time? Why are Vesta's craters such a weird shape with all that lumpy stuff in the center? They're very unusual looking. Let's zoom in on another different crater. This is probably my favorite crater on the surface of Vesta. Its name is Cornelia. And if you're asking to yourself, how come there's white stuff falling down one side and dark stuff falling down the other side? That's the same question the scientists are still asking right now. We don't know why Vesta can possibly have light stuff in one place and dark stuff in another place, all in a very tiny location on the surface. We're still investigating that question. Well, this is pretty much the last photo we got of Vesta because Dawn had to leave. Dawn was on its way to another place in the solar system. And so we have all the data we're ever going to have, probably in our lifetimes, of a close flyby of this world. And Dawn's now on the way to a second asteroid. It's going to become the very first spacecraft ever to orbit 2 different solar system bodies. Anybody know what this one is? It's Ceres. It is the largest asteroid in the asteroid belt. Notice that its shape is distinctly different from Vesta's. Ceres is round, okay? And round makes geologists like me incredibly excited, because in order for something to be round, you have to have enough mass for self-gravity to pull it into a sphere, to change its shape. And that means you have geology has probably happened on its surface. There's probably a really exciting surface on Ceres to study. We don't know. Is it going to look like an asteroid? Is it going to look more like one of Saturn's moons? We have no idea, but we're going to find out because our spacecraft is going to get there in February. So I hope all of you follow along with this particular adventure of a new spacecraft, a new intelligent robot flying to a place we've never explored before. That's coming up very soon. All right. Well, I'm going to take you guys to one more location in the solar system. We could go to Jupiter, we could go to Saturn. I love Saturn. Do check out Cassini's active mission at Saturn right now and explore all its pictures. But I'm going to go even further to a place we've never been before. Here are a couple of pictures of that place. Maybe a little hard to make it out, so let's use the Hubble Space Telescope and get the very best picture that we can get from the Hubble Space Telescope of this location. This is Pluto. This is Pluto and 3 of its moons, Charon, Nix, and Hydra. And Pluto is very far away from Earth, so it's very, very difficult to study, especially if you're a geologist and what you really want to see is what its surface looks like. We have no idea what Pluto looks like. We would really like to see that. We've only had theory for a long time. We have tried to use the Hubble Space Telescope data to get the best information we can about Pluto, and this is the best that scientists can do with all the images that we have from the Hubble Space Telescope. We noticed that Pluto's surface is kind of blotchy. That probably means there's different materials in different locations on the surface, which is really great. Again, gets a geologist like me excited because it means there's probably something cool happening on the surface. But I can't tell you what that is because we can't see it. The people who did this study did discover something really weird about Pluto. These are 2 different maps of Pluto that were made 10 years apart. One map was made in 1994. One map was made in 2002-2003. And you notice that Pluto's surface changed drastically in that time. How can a place that is so cold, so far from the sun, moving so slowly, change so much, so fast? You guys by now should know the answer to that question. We don't know, okay? And so you guys, how does it feel to be exactly as confused as the world's greatest scientists? Okay, that's what you are right now. You're quite equivalent to them. We're all in the same place. One reason why Pluto is so difficult to study. This is an artist concept of what the surface of Pluto would look like if you were floating a bit above it, looking over Charon at the distant sun. Pluto has an atmosphere. And it's not like one of those exospheres that Mercury or the Moon has. Pluto has an atmosphere with enough air in it that there is wind on Pluto blowing around, making weather and climate and clouds and haze. Just think about that for a second. Think about being on Pluto and feeling the wind blowing. Wouldn't that be awesome? Okay, so Pluto has an atmosphere. It's possibly a clue to why it can change so much so fast. It could be that frost form, or you could have things like these little geysers that the artist has depicted in the corner, like we saw on Triton. We don't know what's there, which means our imaginations are free to imagine anything that we want to. I've even heard one scientist say there might be a nitrogen cycle on Triton. You know, like how we have a water cycle on Earth? Pluto could have a nitrogen cycle where you have liquid nitrogen on the surface and nitrogen clouds in the nitrogen atmosphere that rains nitrogen rain that flows across Pluto's surface. I give the odds of that being true about 1%, but wouldn't it be awesome if it were true? And until we have data, we can hope that it was true. But Pluto's atmosphere is a problem because the way that we figure out how big solar system bodies are is by watching those bodies pass in front of a distant star and making that star lights wink out. You time how long it takes for the body to go across, and that gives you a very accurate estimate of its diameter. But the atmosphere messes that up. So it refracts the sunlight around it. We can't tell how big Pluto is. Consequently, we don't know if Pluto is the biggest thing in the Kuiper Belt or not. That's still a mystery. Eris could be bigger. It may be smaller. We don't know. And we're going to have to send a spacecraft there to explore it. We're doing that. We launched it in 2007. It's called New Horizons. It's on its way to Pluto right now. And guess when it's going to start getting pictures? Early next year. So early next year is going to be the greatest time, certainly in my professional career, probably in a lot of your memories too. We are going to be discovering brand new worlds for the first time that nobody's ever seen before up close. And all of you out there in the public will be exploring it and discovering it just as fast as the scientists and engineers working on the mission. So I hope that you understand a little bit more now about the kinds of questions that are driving the exploration of our solar system. They're the same questions that you guys have. How did we get here? How did the Earth form? Are we the same as any other planet out there? Could the same kinds of things that made us on Earth have made life on other planets? We don't know the answers to those questions, and that's what's driving it. We can send spacecraft out there to try to answer our questions. Sometimes we get answers, sometimes we get partial answers, sometimes we're still really confused, and all the time we wind up learning just enough to make lots more questions. So we will never, ever run out of questions for scientists to study. We will never run out of questions for you guys to ask. You will all remain scientists for the rest of your lives, no matter what you do, as long as you stay curious about the world and you keep asking questions and you keep on trying to seek answers to your questions. So I want to thank you very much for your attention. I hope you will follow me on my blog at planetary.org/blog, as I will tell you all the adventures of all the robots exploring the solar system. Thank you very much for your time.